All right, so next on the list, we did sine and cosine, so now we are actually going to be graphing secant and cosecant. As you know, we proved it using similar triangles on the unit circle, but basically, as you know, secant of x actually equals 1 over cosine of x, and cosecant of x equals 1 over sine of x. Okay? So these are two things that you know. We've done this using similar triangles. So now, how do we graph secant and cosecant? Well, since secant is connected to cosine, what we're actually going to do is when we graph secant, we're actually going to graph cosine first. So, for example, and likewise cosecant. When we graph cosecant, we're actually going to graph sine first. For example, so let's say I have f of, we'll do t this time because it doesn't matter the variable. You can choose x, t, theta, whatever you want. Let's go with t. Let's say 3 secant of, we'll do pi over 3x. Oh, nope, I said t. There you go. Pi over 3t plus 5. Okay, so we know that our vertical shift here is 5 and our amplitude is 3. And the period here is 2 pi over 3, right? This is just from our previous lesson on how to graph sine and cosine. This, by the way, gives us 2 pi times now 3 over pi, which is in fact 6. So if I were to graph this, I'm going to do a nice long vertical axis. And here's our horizontal axis right here. And let's label our vertical axis first. And by the way we label our vertical axis is our first vertical shift is 5, so that's easy. Amplitude is 3. Now usually when we graph sine and cosine, we like put it all the way up here. Up 3 would be 8. But 8, I'm actually going to put 8 right here. Not very up at all, mostly because our actual secant graph will actually take place above 8 and in fact below 2. So 5 plus 3 is 8, 5 minus 3 is 2. Now, let's do the horizontal axis. Well, we notice our period is 6, so here's, we'll put 6 over here. Half of 6 is pretty easy, it's 3. Half of 3 is 3 halves. Now, if I want to count out, this is 3 halves, so if this is 3 of them, this must be 6 halves. And so we do 3 halves, 6 halves, 9 halves. Okay, now we are graphing secant, which is really graphing cosine. So what does cosine do? Cosine starts at the top, so this is how I'm going to do it. I'm going to graph cosine starting at the top, going to the middle, going down to the bottom, going back up to the middle, and then back up to the top, right? So here is our cosine graph. Now, we've done this before, graphing secant, but just in case. Now, secant is the reciprocal of cosine. Well, the reciprocal of this height, what happens is the reciprocal of it is just going to be 1. And the reciprocal of this is also like... So when you consider just the basic cosine graph, cosine goes from the center, which is 0, up to 1. The reciprocal of 1 is 1, and so that's why when cosine reaches its peak, secant actually reaches the exact same point. Same with the lowest point, and then the highest point again. The middle is 0, right? For the base cosine function, when you cross the middle, that's generally 0. The reciprocal of 0, though, is undefined. And what I mean by that is it's basically infinity. So hopefully you kind of remember this from one of our previous lessons that we did in class, but you remember these dotted dashed lines that happen to go whenever cosine actually crosses the middle. Now we're ready to actually graph secant, and secant goes out and then uses these dotted lines. They are called, hopefully you remember, think about it for a second. Oops, let's write that again. Vertical asymptotes. Okay, oops, there we go. They're called vertical asymptotes. But anyway, so we go from the center down, and from the center, and we also go down here to negative infinity. So this side is that. This side goes up to positive infinity and up to positive infinity. So the green is the actual graph here. So the green is the actual graph of secant. All right. And that's it. So let's do cosecant here, just a little reminder. So f of x equals, we'll do -2 cosecant of 2x plus 7. I don't know. That seems reasonable. So we'll do our vertical axis here. We'll do our horizontal one right here. Looks like vertical shift is in fact it's +7. Vertical shift is +7. Amplitude is -2. So that means this starts at 7. It's going to go up to 9 and down. Oops, yeah. And it's going to go down. So it's going to go up to 9 and down to 5. There we go. Everything's kind of in there. Then our period is 2 pi divided by 2, which is simply pi. So this out here will actually be pi. In the middle is pi over 2. In the middle of that is pi over 4. And then we can just count out by 1 pi over 4, 2 pi over 4, 3 pi over 4. Now we're ready to graph. First we should actually graph cosecant is the reciprocal of sine. Sorry. So cosecant is the reciprocal of, there we go, cosecant is the reciprocal of sine here. So when we graph this, what we're going to do here is graph sine. Now this is a negative sign, so negative starts in the middle, but goes down. So it goes down to here, then it goes back to the middle, then it goes to the top, just like that, and then back to the center. We then have so then we can draw our vertical asymptotes wherever our graph crosses the center. There we go. And now we're ready to graph our actual function of cosecant, which again will be in the green. So whenever sine reaches its peak, cosecant reaches the bottom of a trough there and then goes up to infinity. Same thing here, but now it goes down to negative infinity. And that's it, and we're done. So that is cosecant and secant. We will then do tangent and cotangent next.